Hello all, welcome to the subject of microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai, Elma Mujay College of Engineering. Well, previous lecture we have seen some introduction part of the LCD, and that is the liquid crystal display. So we have seen what command should be right for controlling the LCD, and what are the hex code we have to write for particular function of the LCD. So we have seen the previous lecture. But in today's lecture, so how we can code that command, we will see in today's lecture, and how we can interface with the 8051. So programming part also we can see in the today's lecture. So today we will going to finish interfacing LED, and another lecture required for interfacing analog to digital controller, and this unit will going to end after some theory part like a programming environment. Some small theory part is left over there, so we will finish in these two lectures. In the next after next two lecture we will going to start the unit 3rd, that is a parallel port interfacing. So we will try to cover all these three topics in the two lectures. So let's begin. These are the command codes to perform some particular operation in an LCD. The command code can be used to display or force the cursor to home position or a blink the cursor. We have to write command like that. In order to display a message on the LCD module, we need to initialize the LCD, and the LCD is initialized by writing the command code into the command register. Initialization comprises of the command code for the clearing the display and shifting the cursor automatically after writing a character and returning the cursor to the home. After initializing, we can write the data to the DD RAM or the CG RAM by ensuring the correct the command and asserting the R by W bar signal low and RS signal should be high, and the data is sent on the port, and a high to low plus is applied on the E pin, and the DD RAM stored the characters in their ASCII code. Character in the internally generated character code. Before sending the command or the data, it is essential to check the busy flag. The flag will be CC and busy, and whether the LCD is ready or not. So before going to initializing the LED, the algorithm should be required to initialize and write to LCD. First of all, wait for a second after for the display to be stabilized. Initialize the LCD by giving the instruction 08238 command subroutine, and wait for a 5 millisecond, and issue the command 0x0F to command subroutine for displaying on and cursor on and cursor blinking, and after that wait for a 5 minutes and issue the command 0x01 for clearing the display command subroutine. Wait for 5 minutes or 5 milliseconds, then issue the command 0x06 for making the LCD in the increment mode, and cursor should be increment after every character and is returned to command subroutine. And after that, similarly wait for 5 milliseconds and issue the command 0x80 to the position the cursor at the first line and first character to, and also issue the data characteristic on one by one, giving their ASCII value using the data subroutine. So these are the initial steps we should keep it in mind. Let's see some of the examples of the command code. So we have to clear the display. So clearing the display, RS should be low here. RS should be low and this R by W bar should be low, which means which is allowed for writing purpose, and this is the data pins. At the last bit should be high. It clears the entire display and set the display data RAM to address 0. So let's see next command code for returning the home. We have to perform same operation and we have to make high bit of this. So if bit is high, this bit is high, then it is nothing but it is sets the display data RAM address to 0 and it returns the cursor to the home position, and the display data RAM contains remaining unchanged data. Then next one is entry mode set. This is the entry mode set. In this term, we should make this bit as increment or decrement. If we have made it 1, then it will increment plus delay, and 0, then decrement plus 0 delay. So S is, and DB bit S is nothing but accompanying the display shift. So this means that it sets the direction for moving the cursor and specifies the shift of the display. These operations are done during the data read and data write. Display on and off control 0, 0, 0, then D3. So at this bit is high is nothing but what will happen. So it sets the entire display on and off and cursor on and off and blink the cursor position character B. So this is the command. So like that we have to write the particular operation. There are a particular codes are there. So we have to keep it in mind, and also some subroutine also there, command also there. Give the instruction to the port, connect to the data bus of the LCD, make the RS equal to 0 to indicate the instruction. So make this R by W bar equal to 0 to indicate the write, and simultaneously we have to make E equal to 1 and 120 microsecond. Wait for the delay is for 120 microsecond and equal to 0 to a latch command and return. So this is the subroutine instructions we have to write like this. Then there are data subroutines also there. So what steps we have to take place in a data subroutine? First we have to check if LCD is ready by calling ready subroutine, and give the data to the port connected to the data bus of the LCD, then make RS equal to 1 to indicate the data. Then make R by W bar equal to 0 to indicate write, and similarly E equal to 1, and after wait for 120 microsecond, and after that E equal to make 0 to latch the data, and we have to return the subroutine. This is the data subroutine. Similarly, there are another subroutines called ready subroutine to make the busy pin, that is the 7 bus is equal to high, to program corresponding port in 8051 as an input port. So, and also make RS equal to 0 and R by W bar equal to 1 to indicate the read, and E equal to 0 and E equal to 1 for make enable accessing, and check if busy pin equal to 0, then if it is 1 indicates LCD is busy. Hence again make E equal to 0, then E equal to 1 and check busy pin and repeat until the busy pin will be equal to 0. So this is the ready subroutine. So this is the some steps we have to consider while interfacing our 8051 with the 8051 with the LCD model or LCD display. We have to write it simultaneously code for two-line interfacing two-line 16-character LCD display of 8051 and using only one port, and write assembly language program to display the message hello on the line 2 of the LCD. So at the line 2 of LCD we should display the message hello at the second line. So here we have to interface our LCD to the 8051 microcontroller to the port 1, and control lines like a RS and R by W bar are driven by the port 3 pin of P3.2 and P3.3 and P3.4, and the voltage at VEE can be adjusted by the potentiometer. This is here. The VE can be adjusted the potentiometer to adjust the contrast of the LCD. So here E is an enable pin, and here the R by W write pin, and this one is a RS pin, register select bit. So these three pins are connected. These three bits, these three are connected with the port pin of this 3.2, 3.3, 3.4. So let's write the assembly language program to display message hello. First we have to initialize our stack pointer here. First initialize the stack pointer here, move 81H. This is the address of stack pointer. Here we are going initializing at our stack pointer from here. So at this address, our stack pointer will be initialized. Then we are going to move A, comma, hash 3CH. So this is nothing but we are using 5 into 10 dot matrix, and which is having data lines 8 bit, and the n row number is n2. So in command port, we can see in a function set row, there is the information how to write this code as given there. So we have to display the message at the second line of the LCD. So we have to move #3C3CH into our accumulator to set this. Then I am going to call the command. I am going to calling our command, and then move A by #0EH. So this is a code for writing. This is a code command for setting the display cursor on. See, we have seen in previous slide. Let's see. So this is the code 0C we have written. 0#3CH is written for making our DL is equal to 8 bit and N is equal to 2. See here in this table 0 cross 0E. This code is used for display on and cursor on. So we are passing in our program this code. See here, we are passing that code into our accumulator to make a cursor on. After that, we have to call again command. Then move A, #01H. So command for clearing the display. This is the command for clearing the display. Now display is on, and display cursor will be on, and display will be clear now. Then move A, #06H, which is used for, this code is using for shifting the cursor to the right. Then again call command. Now our cursor is shifted to the right. Then we have to write a code move A, C0H. So this is nothing but the cursor will shift to the line 2 and position 0. So at that we have to display our message on the line 2. So we are going to setting our cursor into the line 2 and position starting from 0. Then again lcall command. After that we have to move a. Now we have to display our letter H because we want to display hello. So we are going to display one by one here, and we have to call display for displaying purpose. This is a display for the display purpose, and write move a comma hash second letter E. For displaying letter E, then again write I'll call display. Then after that we have to write a comma hash letter L. Then I'll call display. So write like that we have to write each letter. Like that we have to write each letter. See here. First we have initialize our stack pointer here, and the command is written to select 5 into 10 dots LCD display which is having 8-bit display, and line 2 should be need for displaying purpose. And after we should call lcall command, and after that we have setting our cursor on and display and cursor on by writing this code hex code 0h. Then after that we have to lcall command, and after that we have to clear the display by writing the code 01h. After that we here also we have to call command lcall. Each instruction we have to lcall command should be right there. Then after that what will happen, what will we do, we have to shift our cursor for displaying purpose. So displaying our message we should here we should shift our cursor to the right. Then after that we have to lcall command, and after that we have to send this code for selecting a line 2 from the starting position 0. So again call the command line, and after that we have started displaying the letter by writing a particular letter and loading into the accumulator. For displaying hello, first we have to, what command we have to display hello, we have to display this word. We should start from for beginning letter H. Now we have load that letter H into the accumulator. Then we have called lcall display, it will display. Then second letter E, similarly L, L, O, like this we have displayed the message, display the message hello. After that, it should be, after completing the display, it should be jump to here, loop here after displaying the message. So it will here, it will keep looping here only. So it will keep on looping on here. So this is a here. And similarly, we have to write some command for displaying purpose, command routine. So command for routine, command for display and ready routine, we have to write. This is the command, this is the code for writing and displaying the hello word onto the LCD. So there are some few codes are there which should write for subroutine. So what is the code for subroutine? This is the command subroutine. As we know previously, command for command subroutine give the instruction to the port connected to data bus of the LCD and make R is equal to 0, R by W bar should be 0 and make E equal to 1 and wait for 120 microsecond, then make E equal to 0 and return. So we have to write a code accordingly. First L call delay. So sorry, L call ready. First we have to L call ready. Check LED is check LCD is ready or not. Here check whether the LCD is ready or not. So we are calling here subroutine ready, and what the command should be write in a ready subroutine we will see later. For time being, for writing for calling the command subroutine, what will happen inside the command subroutine? It will first call the ready subroutine. After that, it will execute this instruction like that: move p1 comma a. Ensure the command issue the command code here. Then clear P3.2. Because why we are clearing the pin port 3 P3.2? Because we have connected RS pin to this pin. So we are making RS equal to 0 to issue the command. So for that we are clearing this P3.2. See here, RS. We are making RS 0 now. So that's why I have written the code clear P3.2. Then again clear P3.3 is nothing but enabling the writing mode. LCD enables in a writing mode. Then set bit P3.4 is nothing but making enable equal to high here. Making enable is equal to high. Then after that we have to wait some time. After that we have to make this E is equal to 0. Then return. This is the command subroutine. So similarly, we have to write a code for display subroutine. There are a subroutine operation is there. We have to write. So this is the display subroutine. Display routine. Here we have to call lcall ready. Similarly, here also we have to check whether the LCD is ready or not. Then we have to move the port P1 comma A for display purpose. Whatever the data present inside accumulator, we have to load into P1 because the pin of P1 are connected to the LCD display. So whatever the data we are loading into the P1 which is going to display. Then we have to set bit P 3.2, that is RS is equal to 1. To get the data, we have to make RS equal to 1. Then clear P 3.3, because we want to perform a write operation. So we have to perform this bar is equal to 0. By making this bit 0, it will perform the writing operation. Then set bit first 3 P.4 enable is equal to 1, which is enable, and after that clear this bit. After performing operation, we have to wait some time, and after we have to clear this equal to 0. Then we have to return. This is the code for display subroutine. Similarly, we have to write the code for ready subroutine, because we have called here lcall ready. So this is the lcall ready subroutine. Ready routine. For ready routine, what command should be right? Let's see now. So first, make the busy pin is nothing but all the data bus pin high. Then program corresponding port as input port. Then make RS equal to 0, R by W broad is equal to 1 for reading purpose, and make E equal to 0 and make E equal to 1. This is the instruction. So writing this ready subroutine. So how we can, first we have to clear P 3.4, then CLR P 3.2. First clearing the bit P 3.4, that is E, we are going to clear first. Then making RS equal to 0. Then move P1 comma hash 0 FFH. So this is nothing but configure the data pins of all the ports as input port. Configure port 1 pin as input port by writing by keeping all the pins are high. Then we have to set the bit P 3.4. What will happen? This pin, setting this pin. First we have to make R by W bar which equal to high. Is nothing but here going to read operation will be performing here. Then after that, set bit of P 3.4, that's equal to, makes E is equal to 1. Then we have to jump bit P 1.7. Check the D7 bit. If it is 1, then LCD will be busy and wait till it becomes 0. Jump bit. Then it will check the P 1.7. The data 7th bit will be busy or not. If it is 0, then it will be free. If it is not, then it will jump to L1 for waiting purpose. So what is the L1 loop? This L1 is starting from here. Sorry, this is collapsed. This is the L1 here, some spaces in between them. Then after that, write the instruction clear. If the 7th bit of the bus will be free, then we can clear the P 3.4. Clear? So this is the subroutine ready. So few more examples or programs we will see in the next lecture. This is enough for the day. So in the next lecture we will see some few programs interfacing LED and analog to digital converter, how we should interface, and writing some program in this C. And after that some small portion programming environment will be covered in the next lecture. So this is going to finishing unit number 2, and after few one or two lecture, within one or two lecture, these topics will be going to cover, and we will start third unit, parallel port interfacing, and we will cap a small test on unit 2. After that, you guys have to perform the test also.